Understanding percentage conversions and word problems is essential, especially for those aiming to improve their mental math. For such learners, having key percentages like 10%, 12%, or 7% at your fingertips can make problem solving much faster and more intuitive. And so, learning standard fraction to percentage conversions from 1 by 1 to 1 by 19 didn't really build my intuition. I understood where things like 1 by 8 equals 12.5% came from, but even with that understanding, my thinking stayed boxed into the usual suspects. And let's be honest, most of us okay at math folks don't go out of our way to mess with oddball percentages. We just learn what we are given and stop there unless something shakes it up. For me, that moment was what's 88.33% of 606? I knew 8.33% is 1 by 12. Cool. But it took me a few seconds, aka too long, to realize 83.33% is just 10 multiplied by 1 by 12. After that, I started practicing problems with weird percentages like 7%, 4%, 12%, and that's when things shifted. I stopped leaning on fixed conversions and started thinking through problems more flexibly. Still, math wasn't done messing with me. Next up, what's 1 by 23 into 100? Could have done long division, sure, but the solution went another route. Rewrite it as 4 plus 8 by 23. Alright, makes sense. 4 wholes and a left over. Then came the real move. Just pretend 23 is 24 to make life easier. That turns 8 by 23 into something close to 1 by 3. And boom. Now we've got 4.34 instead of 4.33 because it was 8 by 23 and not 8 by 24. At that very second, I thought, wait, we can do that? It felt like watching someone casually pick a lock you've been juggling for 10 minutes. After this little eye opener, I moved on to percentage change, and that's when I met the multiplying factor, aka the tiny trick that suddenly made everything feels 10 times smoother. The moment I learned how to use it, I practically bounced in my seat. Back in school, percentage change was just original value leading to increase or decrease, finally leading to new value. No one mentioned you could just use a fraction and skip half the mess. It was fast, clean, and borderline magical. But of course, just like any good friend, multiplying factor has its off days. Take this one time. If a price decreases by 5%, what's the multiplying factor? I thought, no sweat, 19 by 20. Done and dusted. What I didn't do was convert it to decimal. Later, I saw the answer listed at 0.95 and got hit with mild existential confusion. I hadn't used 100 as a base, didn't touch decimals, so for a second it felt like I'd walked into someone else's math class. Eventually, I pieced it together, split 19 by 20 into 10 by 20 plus 5 by 20 plus 4 by 20 equals 95 by 100, which gave me the 0.95. But the struggle was real. When the question leaned into decimals instead of fractions or percentages, my brain hit pause. That's when it hit me. I couldn't just rely on fractions or percentages. I had to get comfortable with decimals too. Because in a timed test, You don't get to vote on which format shows up. You just hope whichever one you practice doesn't just ghost you. At some point, I came across a new formula for multiplying factor. That is, multiplying factor equals 1 minus percentage decrease by 100. Cool, neat, but also not how I learned it. Personally, I prefer just doing 1 minus the fraction version of the percentage. Cleaner, simpler, and didn't need to involve division unless I absolutely had to. But then came a stretch of questions that totally overloaded my brain. Starting with this one. A quantity becomes 2.25 times the original due to a percentage increase. Was the percentage increase then? Now, this should have been easy. But here's the thing. Give me numbers in clean, no nonsense form, I'm fine. The moment a question hides inside a sentence, though, suddenly I forget how to math. And these weren't just any questions, they were the reverse kind. Instead of giving me the percentage and asking for the new value, they handed me the end result and wanted me to work backwards. And my brain went, wait, they want me to reverse engineer this problem in words? Oh no, I don't do that. Eventually, I cracked it. 2.25 times the original is 125% increase. Nothing wild, fairly elegant, actually. But after enough of these, I realized I'd been so deep in decoding these backwards, word heavy questions, I'd completely lost touch with what multiplying factor was supposed to be doing in the first place. Like, I had gotten so good at turning the machine inside out, I forgot how it runs. It got to the point where I came across this gem of a question. A salary decreases by 12.5%. What's the multiplying factor? And I just sat there, glaring at the question like, who even invited you? The irony? This was the kind of question I used to wait for. Clean, direct, no sneaky wording. But thanks to all that backward decoding, my brain went rogue. I thought 12.5% decrease? Okay, multiply by 1 by 8. Yeah, multiply by 1 by 8. That's where I was. Look, if you're face palming, don't worry. I beat you to it. The correct thought, of course, was 12.5 degrees equals subtract 1 by 8. Multiply by 7 by 8, that is. So 0.875 or 87.5% is the answer. Guilty as charged. I'd done harder stuff, and here I was tripping over the thing I once considered a comfort question. So yeah, after all that fraction, factors, full-on brain fog, I figured it was time to step back, laugh at the mess, and actually make sense at all. Because crunching percentages, juggling multiplying factors, and untangling fraction logic is one thing. Figuring out why your brain derails mid-question, that's something I consider real. Here is what stick with me. First, memorizing standard fraction helps but only gets you halfway. You need to get your hands dirty with the weird percentages too. Second, it's okay to blank out on the easy stuff after wrestling with the hard stuff. Just don't unpack and live there. Third, sometimes you don't need more tricks or shortcuts. Just a second to zoom out and see the problem for what it is, not what your brain made it into. Oh, for the fun fact, by the way, it can also be applied to life. Fourth, You can be good at math and still freeze when the question is in full sentence form. Fifth, the more effort you put into advanced problems, the more likely you are to blank out on the easy ones later. It's science. Or sabotage. 6. Some days I'll come back to this is the most correct answer you'll give. Signing off for now. Next time we ride the roller coaster of successive percentage changes. Buckle up. Bye.